All right, Biology 11. Our next unit is evolution. In French, that would be évolution. This is our intro topic today. As usual, the same format as followed. Our notes from the D2L site, the ones that you were printing off or getting into your notes, are going to be on the iPad here up in the corner, and I'll use the whiteboard to write down certain key terms or supporting arguments or diagrams. So, today's lecture actually is not about the accepted way that we think about evolution just yet, which is natural selection. It's about all those ideas that Charles Darwin, the guy who came up with natural selection, all those ideas that he used to get there. Quite often in science we see when someone makes a big discovery, they kind of, you find out later on, they relied on that person's work and took a little bit of that, and then, took some of his work or her work and used some of that. So they gathered ideas and information from several different sources, and that's what we're looking at today, of these early ideas that helped Darwin get to the point where he could come up with a theory of natural selection. So, and keep in mind this, changing a species, which is what evolution is, changing a species over time, it takes a long time. Almost as long as it takes to change some people's minds. We're going to see here this idea in biology. Out of all the things that we look at in biology, evolution was the most hotly contested one. At the very beginning of its infancy, a lot of people did not want to believe in evolution. They had a few problems with it. We'll go into those problems a little bit in this lecture and in some future lectures. So our first idea is creationism. Creationism is basically the creation story in the book of Genesis of the Bible. Right? On the first day, God created this and this. On the second day, God created this. I believe humans were the sixth day, and on the seventh day, he rested. Using the Bible and other religious documents, an archbishop in Ireland, James Ussher of Armagh, he calculated the date and time of creation. So when the earth was created, to be 4004 BC. And then you go through the 4004 years to get to the switch point between BC to AD. And we are now currently at 2020 AD. So using a little bit of math, you can see that he said roughly 6,000 years ago, the earth was created. Now, science pretty much refutes this, right? And I'm not here today to refute God by any stretch of the imagination. I personally believe science is the art of uncovering God's handiwork, right? But the Bible and other religious documents are filled with tons of analogies, symbolism and things like that. So you can't always just take them directly at their word. Some people still do. I've actually met people who do believe the earth is 6,000 years old. It seems weird, with me being a scientist, that people would believe that when there's all of these techniques and things used, processes used by science that have dated fossils and layers of the earth and various other things to be much, much older than this. But this is the age of the earth according to strict creationist thinking. In these days, animals and living things were thought to be immutable, which means when it comes to change, there was no change. Now, evolution is a change in species over time. Strict creationist theory says, no, there's no change. God made these things. They don't have to change because they are perfect. God doesn't make mistakes. He made them the way they were. Correct? So you can kind of see where evolution and religion, creationist theory, would kind of butt heads here. And that's part of the reason why Darwin was not very popular when he first came out with his theory of natural selection, explaining that things change and new species can arrive from old species. People were not ready for that. They were still very, very much under control of the church and God, and feared speaking out against either one. Fossil evidence, of course, if we look at the fossil record, there's tons of fossilized remains that are of creatures that don't look anything like anything we have on the planet today. We go and find a T-Rex, right? Thank God there's not T-Rexes running around today, or a Brontosaurus, or a Triceratops, or a saber-toothed tiger. These things have gone, right? If you use immutability, it means at one point we were all walking around on the planet at the same time, right? We walked around on the planet at the same time as T-Rexes and that. It just doesn't kind of make sense to me. Our next idea is catastrophism. So catastrophism, a catastrophe. A catastrophe is something bad happening. So we'll see how this relates. So Baron-Georges Cuvier studied fossils. And what he noticed that many of the fossils that he found as he was digging through the various layers of the earth no longer looked like stuff that was living on the planet. We just said that, right? Like there's no T-Rexes around here anymore. Where did the Brontosauruses go? I don't see them around here. Nothing looks like these things. He also noticed that if we look at the earth, here's me and you, and we're standing there on the earth. As we go down through the various layers of the earth, this is the most newly formed layer of the earth, and this is the oldest, right? This one has been formed long, long, long ago. This layer of the earth is the relatively newer one. So basically, as you dig deeper, the fossils and the layers of the rock get older and older and older. And what he notices that a creature here, it wasn't the same as a creature there. There may be some similarities, but there are a lot of differences too. And a creature here, and a more recent layer of rock, yeah, it had 4 legs, or maybe it had teeth, or there were some similarities, but it didn't look exactly like these. And there's another thing in this layer of rock which maybe kind of looked like these, but had different features. It wasn't the same, exactly the same. And maybe that even resembled something on the earth today that kind of looked like this, but there were changes. And so you're thinking, oh, this guy's got it. He's going to say that there was a flow of form in the fossils. Right? You're thinking, this guy's going to say, well, this changed over time and became that, and then that changed over time to become this, and then that changed over time to become that, and that became that. That is not what he said at all. He took a totally opposite, different direction here. You're thinking, you know, there's going to be a flow of form. Environmental change led to a change in these creatures. Nope. Instead of evolution, change over time, and flow of form, he said catastrophism occurred. He used the idea of catastrophism, where basically these large-scale catastrophes, like Noah's flood, would come in and wipe out these other things. So all of these things, instead of this evolving into this and this and this, all of these things were on the planet at the same time. And something like Noah's flood, they didn't get on the ark. There was no space for them, perhaps, or they weren't chosen. So these creatures, these fossils, are there because they couldn't make it onto Noah's ark for one reason or another. They got buried in the mud and that of the flood. I'll go with flow of form personally. So to explain why fossils were there, oh, they got buried in the flood, but it didn't explain how they kept becoming more and more complex and seemed to change over time. That wasn't explained by catastrophism. The next couple of ideas. Actualism. Now these next couple of ideas refer to the earth, which is basically the environment animals and plants and that live on, you and I as well. So keep that in mind. The environment and the earth, we're going to be talking about that with these. So for actualism, we'll be talking about a geologist, a Scottish geologist named James Hutton. A geologist studies the layers of the earth, how the earth is formed, how it erodes, how how mountains rise, things like that. He was also a naturalist. So he proposed this idea of actualism, and he said basically the same forces and geological processes that were occurring eons ago are still at work today. Things like tides, erosion, the formation of new land masses, volcanic activity, all that stuff that's going on today was going on thousands and thousands and millions of years ago, right? So basically, the earth and the environment is being acted upon now by the same forces that were acting upon it years and years and years ago. And that's basically it for actualism. That's going to get us into our next idea. So that understanding that the earth, the same forces, tides, erosion, that were acting on the earth then are still acting on it now, is going to help us with our next idea. Our next idea is uniformitarianism. This one is Hutton. And uniformitarianism, I'll leave these on the same board because they actually, one leads into the other, and you'll see that. So uniformitarianism, that was put out by Charles Lyell. Lyell read Hutton's work and added some things to it, right? We just talked about that. Scientists use other scientists' work. So in this he stated, the very first point sounds just like actualism. The earth is being affected by the same processes in the past as what's going on right now. One thing he addressed, and I'll put it in red here, is the idea of change. He said basically change is slow and gradual. More often than not, if you trace back through history, year after year after year after year, the environment really doesn't change a whole lot. And if it does, it's very little. It's a very slow, gradual change. Hardly ever do we see anything catastrophic like, oh, look at that layer of the rock, and the one right next to it is totally different. We don't see that very often, right? And he said natural laws and processes are constant and eternal. Gravity's the same as it always was, and other different things like that. So the same forces that are acting on the planet are still acting on the planet. These forces shape the earth, and they shape the environment. And we know that the environment is going to play a huge role on the survival of species. If the environment is friendly and nice, life is good. Numbers go up in terms of population. If there is a change and it starts to get bad, numbers will drop. Members of the species will die. The entire species may die and go extinct. So that's why these are important. All right? So by saying the earth changes very slowly and gradually, we're basically saying environmental change, for the most part, is very slow and very gradual. All right? Buffon. Now, Buffon, in terms of people that studied science, he might rank third overall. Darwin would be ahead of him, and maybe one of the ancient Greeks would be ahead of him too. But Buffon put out some really important things. So basically, what Buffon did, he was the first scientist that kind of suggested that a species could change over time, right? One of his very famous examples, they had found a mammoth. And he goes, oh, could it be that the mammoth over time becomes an elephant? And this is the thing. What he's saying is that this slowly changes into this. He's suggesting that. So there is the element of change, and evolution, we know, is all about change. But what kind of, gets Buffon and discredits him is Buffon believed in immutability. So you think, well, how can he talk about change and immutability? Darwin is going to say this species changed over time and became a new species. Buffon would have you believe that the mammoth basically just got bald and lost its hair and became the elephant. It's still the same species. The same way that somebody shaving their head is still the same person. So that's kind of the thing. Buffon still was a proponent of immutability, right? But he had several great ideas. The idea of change in a species, right? Not changing species from one species into a separate one, but change where these would be the same species. But that idea of changing over time was huge. He was one of the first to suggest it, not Darwin, Buffon. And that change is called evolution. He also developed a concept of unity of type. Unity of type looks at physical characteristics and says, wow, look at these things. A lion and a tiger and a jaguar. They have some very similar physical characteristics, these large predatory cats. And so we saw that in diversity. We used similar physical characteristics to group things in similar kingdoms or classes or genera, plural for genus. Excuse me. So comparative anatomy does that. So he was one of the first people to kind of bring that idea into the realm of biology and evolution, right? He also talked about inheritance from parents. Right? Just like we can look at things, we can look at dogs or people or whatever it is, and we can kind of pick that, wow, I bet you the bulldog came from those other two older bulldogs. You wouldn't think the bulldog came from the two German shepherds or the two chihuahuas. So he noticed that inheritance came from parents. He couldn't prove how it worked. He had no idea what DNA was. That would come much later, right? Mendel was working on this as well. But he knew, he said, there's a connection there. He knows that there's something in the parents being passed on to the offspring, the kids, that is contributing to them looking the way they do, right? Parents and kids have similar physical features. So these two ideas are connected for sure. One of the other things he also brought into the realm was the struggle for existence. Basically, what you guys would say is that life is a grind, yo, right? Life is a grind, right? It's hard to survive. You got to find water. You got to find food. You got to find a mate to propagate the species. You got to not be food for something else. You got to find shelter. There's a lot of things, right? I often think of Mother Nature there with her clipboard, her checklist of what you have to be able to do to survive, right? And if you get enough check marks, you survive. You get enough X's, you die. That's a struggle every day to meet those requirements. And Buffon was one of the first ones to say that life is a struggle for existence. It's a grind. So all of these things, again, the thing that gets him is that he still kind of held on to the idea of immutability. And that's what, that's why we're reading about Darwin rather than Buffon right now. All right. This next person, Thomas Malthus. Now, Malthus, I'm going to put him in red. He's really important. Malthus, one of my favorites. So Malthus, he looks at population. He's studying the human population. So he's looking at our population numbers, and he's doing this in the 1800s. All these people are working in the late 1700s to mid-1800s. And he's looking at the population of the earth in terms of people, human beings. And he's already going, oh my God, there are way, way too many people on this planet right now than what the planet can provide for. The planet doesn't have enough resources to provide for all these people, right? You can imagine if he was around today in 2020, he'd lose his head. Anyway, so he said, an unchecked population is one that will just continue to grow and grow and grow and grow, kind of like people, right? And he's looking at, well, what effect is that going to have? Because he noticed that the human population was doing this, but then when we hit the 1800s, it starts to do that. It was climbing very gradually at first, but now we hit right around the mid-1800s, and it's started to increase quite a bit. It's going to end up going like this pretty much over the next number of years. But he's starting to realize, oh man, we're doing this right now. What ramifications is that going to have on our planet that we live on? So he said this, and I'll read it quickly and then we'll talk about what it means. The power of population is indefinitely greater than the power of the earth to produce subsistence for man, which means our population demands so much more resources than what the earth can possibly provide. Population, when it's unchecked and just allowed to climb like crazy, it increases in a geometric ratio. But the earth's resources only replenish in an arithmetic ratio, which means the earth can kind of keep up with this. I'll put the earth in green, which means while we're starting to do this, the earth is still kind of doing that, the green line. And he said there's going to be a divide between what we're taking from the earth and what the earth can sustain or replenish for us year after year after year. So what happens if we continue to grow in this direction and the earth can only provide in this slightly upward line? Well, he says the power of population, the red line here, is so superior to the power of the earth to produce subsistence, resources, for man, that premature death must occur. All right, so what's going to happen as this divide gets further and further apart? Premature death. Now, premature death means you're dying before your time, right? It doesn't mean that you're dying when you're 90-something. You've lived a good long life if you've made it into your 90s. That's a natural death. Premature death is an unnatural one. It's dying before your time. So, how does that happen? Well, there's two things that are going to bring that population down, because premature death is going to do that. Premature death is going to try to bring this red line down closer to the green line, right? And he said there are two types of checks that are going to bring a population back in. You know, the ironic part is, in nature with plants and animals and all of that, we see these checks brought into play. Humans have somehow, because we're so smart, have defied it to this point, right? So there are positive checks which are going to raise the death rate. So more things are going to die, and that's going to bring that population back down towards a green line. And then there are preventative checks, which are going to lower the birth rate. So we won't have as many people being born or as many organisms being born, and that'll keep us close to the green line. So we're either going to kill off a bunch of organisms, or we're not going to have them reproduce at the same rate where it's just going to keep climbing like crazy. Again, we aren't seeing these so much in humans, but we do see them in a lot of the animals and plants that have to live in Mother Nature's realm. We kind of have escaped it. So Darwin would use these great ideas greatly in terms of survival of the fittest. When life is a grind and premature death is on the doorstep, who survives and who dies? The fittest are going to survive and escape premature death. Before we get into the next thing, premature death, I read further into Malthus when I was in university because I really liked his stuff. And so death is going to come in one of three ways, right? The first way is famine. Famine is lack of food, right? Famine is people starving to death. And we see that in third world countries. Ethiopia, Somalia, people do die because the climate there and the land just isn't suitable for crops that are food-bearing crops. And so famine kills people before their time. People starve to death. There's too many people, and the earth only has that much food in those places. And so famine kills people. The second one is pestilence. Pestilence is disease. And we're seeing that now with this virus. The cases are going up much higher per capita in heavily populated areas, right? So we see it, it's gone really hard at some of the, big cities in Italy. Toronto has more cases than towns in the Durham area. Toronto's more highly populated, dense, right? Montreal has way more cases. So New York has a ton of cases. So in what happens here is that in very high populated areas, again, our population going up, disease is more easily passed, right? And this is part of the reason why we're socially isolating right now, is that we want to break those connections so that disease cannot pass, and we'll stay safe in our homes. And as long as we follow that protocol, we should be fine, right? So, pestilence, the population goes up, means more people are living right next to other people, on top of other people. You can imagine some of the cities in China and that, right? And that makes disease more easily spread when people are in close association to each other, right? And the third way is war. When resources are limited, the earth only has this many resources, and this many people have to get those resources, whatever they happen to be, water or food or whatever, they fight over them. And so what happens is, through war or conflict, people die. If you've taken grade 10 history with Mr. Zimmer, Mr. Sesslon, or Mr. Stanisek, you know all about this. You know that the great wars have killed many, many people, right? So if we look at this, death, famine, pestilence, and war, these are the four horsemen of the apocalypse. If you go back to the Bible in the book of Revelation. So it's kind of an interesting connection there, how like we're kind of pushing away from the Bible, but then there's something that's similar to one of the stories in the Bible. Anyway, I do not believe we're going to the apocalypse. I believe if we're smart, we will get through this. Please do not, turn my words into me saying life is over on this planet, right? Life is good. We're going to get through this just fine. But it's worth mentioning here. Our last idea before we get to natural selection comes from a guy named Jean-Baptiste Lamarck. Lamarck was the first biologist to recognize the role of the environment. So acquired characteristics what did Lamarck bring into it? The environment. I'm not spelling that very well. Here we go. Environment plays a role. So Lamarck is one of the first people to say, hey, the environment's huge here. Right? Now we talked about the environment changing in some of the earlier things, actualism, uniformitarianism, but those guys were just geologists. They were talking about how the planet changes very slowly over time. They never made a link to living things. Lamarck makes that link. He says, look, the environment, picture Mother Nature with her checklist. She plays a role in determining how creatures look the way they look, why they behave the way they behave, because they have to fit into her grand scheme of things. She's got so much food, you got to be able to get food. If it's up in trees, you got to be able to get it. If it's under the ground, you got to be able to get it. If it's under the water, you have to be able to get it. These are the predators that are in this environment. If you can't escape them, you're going to die. So the environment plays a role in shaping the characteristics of creatures and changing them over time. If the environment changes, so will the creatures. So he states that animals strive to survive by using or not using, not using various parts of the body. The ones that they use over and over and over again to survive that help them, they'll become more and more enhanced. Accentuated was his word. They'll become stronger and more prominent. The ones that we don't use tend to wither away. A couple of really good examples, right? One of disuse, our appendix. Evolutionary biologists believe our appendix was something that helped us digest grass and branches and bark back in the day. Well, we don't eat those anymore. So the appendix has started to wither away, and it's just become this useless little leftover of our evolutionary past that's still in our body. But it doesn't do anything really useful for us, right? But the opposable thumb, when that came along and allowed us to grab things and the ability to use tools and all the, make tools and use them, these things are huge. So that opposable thumb, that's awesome. That really has helped us and has become more and more accentuated, right? Our brains, humans, our brain cavity and our brain size has increased over time. And so we're very, very smart. And that's part of the reason why we can beat the curve that Malthus described. So things that help us become more accentuated, obviously we want to keep those around. Things that don't, they go away. These enhanced traits get passed on to the next generation, right? I have an opposable thumb, so do the offspring. right? The problem is this: you're thinking, wow, that sounds like evolution. He got it. Well, not quite, right? So we have the animals and plants that live in the environment. I'll say animals, all living things that live in the environment, right? We know that Mother Nature, the environment, that's who's in charge. As this rolls, so do they. This changes, there's be a resulting change in these. What Lamarck said was that animals, or the organisms themselves, they can direct the change. Which is basically saying, if I want it, I can get it. A great example, a common example, the giraffe's neck, right? We know the giraffe has a long neck because through random change and mutation, the ones with the longer necks could feed, ones with shorter necks can't feed, so they die. And only the genes of the long-necked giraffes go on, and they have offspring that have long necks. What Lamarck said is, yeah, giraffes have long necks because they want to be able to eat off the trees. Sounds good. What he suggests is that because the animals want it bad enough, the giraffe wanted to eat it, the giraffe stretches its neck and stretched it and stretched it and stretched it and kept reaching and reaching. And as its neck stretched a little bit, that would be passed on to the next generation of giraffes. Then they would crane their necks and strain them and eat. And eventually, through the animal's own desire, they want it, they desire it, they can change. Well, that's like me saying, you know what, I hate riding around in traffic, so I'm just going to grow wings and fly, and I'll get home much quicker every day. So I think hard enough, wings. Well, that's not going to happen, because we know that the connection between our traits and our abilities goes back to our DNA, right? So if I'm going to have wings, then I've got to change my DNA, because it's my DNA that builds me. And that's the thing these guys didn't know about. So he thought, oh, if the animal wants it bad enough, they can work at it and get better at it and stretch their necks or develop wings that are bigger for, or faster, whatever it happens to be. That helps, I'm going to develop it. Well, traits go back to DNA. So if I'm going to, just because I want it, change my traits, somehow I'm going to have to go in and basically reorganize or change my DNA. And I can't do that. It's impossible. So basically, Lamarck is that guy that almost gets it there. He's almost in the end zone, and he falls down at the 4-yard line and falls just short. The animals aren't directing the change. The environment is. What Mother Nature does is she gives you her checklist every day of things you have to do. How do you get check marks on your checklist? It's these traits. If the traits are a good fit, you get check marks. If the traits are not a good fit, you get X's. If you get a bunch of these, you survive. If you get too many of these, you die. Mother Nature basically is picking who has the best traits. They get to survive. So Mother Nature, the environment, is picking who has the best DNA. We aren't picking our DNA and reorganizing and mutating our DNA on purpose. It happens randomly. Sometimes it works for us, sometimes it doesn't. We don't direct that. Mother Nature directs what survives and what doesn't. Anyway, if there's any questions, comments, or concerns, please throw them into the comment section of this YouTube video, or reach out to me through Edsby. Our next talk is going to be Charles Darwin. So we're right at the point now, we're ready for Charles Darwin and the theory of natural selection. That will be our next YouTube lecture. Those notes are on your D2L page, and that's it. And what we'll see as we go through Darwin's work is the connections made back to these things. All right? And of course, you know what grinds my gears? People that believe in creationism and immutability and get a flu shot every year. If you think about it, kind of makes sense. Anyway, we'll talk to you later. Hope you enjoyed the video. See you soon. Bye-bye.